Welcome to your 8-9 podcast. Before we get into 8-9, we're going to do a couple things. One is we're going to go over your 8-3 through 8-5 quiz. Now, this quiz is all about being able to apply those formulas we talked about. So for the first one, notice you are looking at an infinite series, okay? And you are looking at the sum of this infinite series. Now, the first thing I would do is look at the numbers and check out the pattern. So the pattern, it's not a constant difference. You're not subtracting the same amount every time. So what I would look for is a constant ratio. So check 5.6 divided by 7 and see if that's equal to 4.48 divided by 5.6. Always take the second term divided by the first term. Okay, and you get 0.8 on both of those. So you know it's geometric and it's an infinite series. So I'm going to go S sub infinity will be g sub 1 divided by 1 minus r. So my g sub 1 is 7 divided by 1 minus 0.8. So my sum ends up being 35 if you calculate that correctly. Okay. Second one. Find the sum of the first 40 terms. Okay. Notice the pattern this time is subtracting 8. Okay. So this one is arithmetic. And I know the difference is minus 8 because this one's a little more obvious to see. And I'm adding together the first 40 terms. So what I'm going to use is this formula. N divided by 2. 2 times the first term plus the difference times n minus 1. Okay, so I'm going to have S sub 40, because I'm adding together 40 terms, would be 40 over 2. 2 times the first term of 60 plus the difference of negative 8 times 40 minus 1. Okay, and then the answer you should get is negative 3,840. Okay, next one. This is using that sigma notation, but take a look at the formulas they give you. Okay, those two formulas, the top one looks like a geometric explicit formula, and the bottom one looks like an arithmetic explicit formula. So when I do these calculations, since it's sigma, I'm adding up all the terms. This is a geometric series. Okay, and then the guy on the bottom is an arithmetic series. Okay, so notice when I use my geometric series formula, it's S sub n equals g sub 1, and then 1 minus r raised to the n all over 1 minus r. So let's fill this out. Okay, so my S sub, I'm adding together 30 terms because I'm going from 1 to 30, is going to be g sub 1. Plug 1 into the formula. Okay, you get negative 9 for the first term. And then 1 minus the ratio. The ratio is negative 3 raised to the power. In our case, is going to be 30. Okay, and then 1 minus the ratio on the bottom. Now notice on top, you cannot change 1 minus negative 3 to the 30 to 1 plus 3 to the 30. Okay, those negative signs do not cancel each other out because the 1 that's on the 3 is raised to the 30th power and the subtraction is not. Okay, so when you do this calculation, you should get something like 4.63 times 10 to the 14th. Okay, now the last one. I'm going to use one of my series formulas. And actually for this one, I'm just going to use this version of the series formula, n over 2, a sub 1 plus a sub n. Okay. Now the first term that I'm adding up, I get by plugging in 4. The last term that I'm adding up, I get by plugging in 35. So the first term that I'm adding up actually ends up being 18. The last term that I end up plugging in ends up being 2 times 4 times 35, which ends up being 142. And now, how many terms am I adding up? I'm starting off with the 4th, going up to the 35th. So if you subtract those two, it's 31, but you got to add on one more. So I'm adding up 32 total terms. So 32 divided by 2. I'm finding the sum of 32 terms altogether. So this is the calculation I'm going to do. And I'm going to get 2,500. and 60. Okay, now today we're going to take a look at section 8.9, which is binomial probabilities. And so what we're going to do is we're going to talk about these probability situations, and we're going to take a look at how they're connected to some of this combination Pascal triangle stuff that we're going to take a look at. And then we'll show you how to actually do the calculations. Okay, so if you take a look at section 8.9, okay, the situation that we have is the following. John Schuster is on the Olympic curling team. When he throws the rock, he makes his shot 83% of the time. Assume that each of his shots is independent. So our end goal is going to be this. What's his probability of making 3 or more of his next 5 shots? That's part C. But we're going to start with an easier question first, okay, which is part A. What's his probability that he makes 5 out of 5 shots? Okay, so he's taking 5 shots, and there's an order to them. There's a first, second, third, and fourth shot. So, and we're assuming that, you know, it's 83% each time, so each of them are independent. So what we learned back in chapter 7 is that you can multiply these probabilities together. So now we're going to say he's making all 5 shots. So I'm going to use a little X for a make. What's the probability that he makes it? Is 0.83. What's the probability that he makes the second one? Is 0.83. Makes the third, fourth, and fifth will all be 0.83. So all I got to do is multiply these things together. Okay, so obviously it ends up being 0.83 to the fifth. Okay, so it looks like that. And my answer ends up being 0.3939 approximately. Okay, now let's switch the question. I want to know the probability he makes 4 out of 5 shots. Okay, so now I'm still going to have those same 5 slots because he's taking 5 shots in order. Okay, but here's the deal. If he's making 4 out of 5, we don't know which one he misses. Okay, so for instance, he could make the first, second, third, fourth, and miss one. Okay, he could make the first 3, miss one, and make the last one. He could miss the middle one. He could miss the second one. Or he could miss the first one. Because there is an order to the shots, okay, these 5 scenarios are technically different scenarios that'll give him 4 makes and 1 miss. Okay, now let's just take a look at the probability of the top one. Okay, so the probability that he makes his first shot is 0.83. The probability of the next one is 0.83. Probability of the next one is 0.83 and 0.83. Now the probability that he misses the last one, you got to remember this, is 0.17. So I got to multiply by 0.17 there. And now I can do this calculation, which is just going to end up being 0.83 to the fourth times 0.17 raised to the first. Okay, so now that's the probability that he makes the first 4 and he misses the last one. Okay, so we just did this. Use a different. Now, what's the probability here? Well, what you should notice is it's going to be all the same numbers, just in a different order. Okay, and the same is going to be true for all of the other arrangements. They're all going to have 4 0.83s in them and 1.17 all multiplied together. So instead of doing each one individually, all I'm going to do is multiply by 5. And do this calculation. And this ends up being 0.4034, something like that. Okay, now our last question, which kind of goes back. What's his probability of making a 3 out of the next 5? So set it up the exact same way. Okay, 1, 2, 3, 4, 5. All the probabilities are going to be multiplied. But in terms of makes and misses, they could come in any one of a number of orders. Okay, so he could make the first 3 and miss the last 2. Or he can make the first 2, miss 2, make the last one. It could look something like that. So next, try to list out all the possible ways he could have 3 makes and 1 miss. So now I just listed them all off, okay? And notice there's 10 of them. But as you guys might have noticed, it's really easy to miss some, okay? But what you should notice is there's 10 altogether. And then if I go to my little slots, how am I going to fill them out? Well, on all of them, 3 of the probabilities are 0.83, and 2 of the probabilities are 0.17. So what I'm going to have is I'm going to take that 10, because there's 10 different ways to have 3 makes and 2 misses. I'm going to multiply by 0.83 raised to the third times 0.17 raised to the second. Okay, and do this calculation, and then 0.1652. Okay, so now these situations, okay, are all examples of something called a binomial experiment. And these are the properties of a binomial experiment. There are repeated trials or situations. So John Schuster here was taking 5 shots. Those are our repeated trials. There's only 2 possible outcomes, success and failure. He either makes the shot or he misses the shot. The trials are independent, and if you remember, that means they don't change, the probabilities don't change, or you don't change one another's probabilities. And then 4, each trial has the same probability of success. And then number 5, the experiment has a fixed number of trials. Okay, so these are the 5 things that make up a binomial experiment. Now, how do we calculate the probabilities associated with a binomial experiment? Okay, well, we do it just like we were doing in these problems. But the big question is, it's easy to see where the 0.83 comes from and the 0.17 raised to the 2 powers. But how do you get that number out in front? There's got to be a better way. Okay, and basically what it ends up being is it ends up being a combination. Okay, so if you're given a binomial experiment with n trials, the probability of having k successes is this. Okay, you're going to do a combination. Okay, where n is the number of trials, k is the number of successes. P is going to be your probability of a single success. Q is going to be your probability of a single failure. Okay, and pretty much what these are, the k, again, just like it says, is the number of successes. And then this n minus k is the number of failures. Okay? So what we're going to do here is go back to John Schuster, and we're going to talk about his probability distribution. Okay, and this is on the, or we're going to talk about his probability distribution, which is all the probabilities that make up a binomial distribution. So what we're going to do, just like we did back in chapter 7, if we're going to write out a distribution, is make a table. Okay, so on my table, on the top row, I'm going to list out the number of successes, or the outcomes, the possible outcomes. So for Mr. Schuster here, he could either make 0, 1, 2, 3, 4, or 5 shots out of 5. And then we're going to figure out the probabilities of each one. So now, so far, we've calculated 0, 1, or sorry, we've calculated 5, 4, and 3. Okay, so we've already done these. Now, instead of making the big long lists that we made, we can actually just write them out like this. So instead of making the list to figure out 10, I can instead just use 5C3. Then multiply by 0.8 to the third, and then 0.17 to the second. Okay, now if I want to figure out the probability that I'll make 2 out of 5, well then I can do this a little easier now. I'm going to start off with the combination rather than listing out all of those X's and O's. So I'm going to go 5C2. Your probability of success is again 0.83. I'm going to have 2 successes because he's making 2 shots. And he's missing 3. So I'm going to take 0.17 raised to the third. Okay. So what I can do is I can do that for 2. I can do that for 1. And I can do that for 0. Okay. We'll practice this more in just a second. But this is what's called a binomial probability distribution. Okay, and I could go through and find all these probabilities, do all these calculations. So like for instance, this is 0.000142. This guy is 0.003466. This guy is 0.0333846. This guy is 0.165246. 0.403396. And my last guy is 0.39904. And now, just like regular probability distributions, all of these values should add up to 1, and these represent all the probabilities that could happen. Okay? So now let's do a couple things. Let's actually kind of try out some of this stuff. Okay? So the first one that we're going to do is example C. Let's go to example C. So you have a quiz that has 8 multiple choice questions, each with 4 choices. If a student guesses randomly on every question, what's the probability of getting exactly 6 or more correct? So this is what I'm going to have you do on every one of these problems. Just like we talked about the properties of a binomial experiment, I'm going to basically have you list them out. How many trials are there? Well, if it's an 8-question quiz, there's 8 trials. Okay. What's your probability of success? Okay. Well, if you are randomly guessing on a question that has 4 choices, okay, your probability of success is going to be 0.25. Okay. Now, if you want to list out your probability of failure, feel free, but you don't have to because you could figure it out from the 0.25. Your probability of getting the question wrong is going to be 0.75. And now lastly, the K is the number of successes. The one weird thing about this question is that it says 6 or more. Okay, that or kind of being key here. Remember that meant union. That means if he is 6 or more out of 8, he could either have 6 correct, 7 correct, or 8 correct. So what ends up happening is we're just going to do this problem. We're just going to use the formula a couple of times and add it up. Okay. So now let's find the probability. And again, instead of listing out all those X's and O's, makes and misses, I'm just going to use the formula. So what's the probability of getting 6 correct? Well, I have 8 total. So 8C6 is the combination I'm going to start with. I'm going to multiply by the probability of success, which is 0.25, raised to the number of successes, which is 6. Then multiply by the probability of failure, raised to the number of failures, which would be 2. And onto this, I'm going to add on the probability that we get 7 correct. So it'll be 8C7. Probability of success is 0.25, raised to the number of successes, which is 7, times the probability of failure, which is 0.75, raised to the number of failures, which is 1. And then lastly, what's the probability of getting 8 correct? So I'm going to go 8C8 times 0.25 raised to the 8th times 0.75 raised to the 0. And then just do this calculation. Add these 3 together. So when I add these 3 together, I get 0.004227. And that's a pretty low probability, but let's kind of make sure this makes sense. If you have a 1/4 chance of getting a question right on an 8-question quiz, you'd expect to get around 2 correct. We found the probability of getting 6, 7, or 8 correct, which would have a pretty low probability. Okay. Now the last one that we'll do here, the probability of getting 7 or fewer correct. I'm just going to set it up the exact same way. How many trials do I have? 8. What's my probability of success? 0.25. What's my probability of failure? 0.75. Okay. And then what's the probability of getting fewer than 7? Okay. My K values, what I'm finding, this is not just a single formula or a single probability. My K values are going to be everything from 0 to 6. Now, if I were you, I'd be going, oh my gosh, Mr. Schmidt, how could you ask me to use this formula 7 times and then add them all up? That is a pain in the butt. Okay? Well, notice what we have here. 0 through 6 is what I want to add up. but there's only 8 trials. So that means I left out 7 and 8. If you think about what we said with complements last chapter, basically all of these probabilities, if I did them all, if I did all 9 of them, because there's 0, 1, 2, 3, 4, 5, 6, 7, 8, should add up to 1. So instead of using the formula and doing it 7 times and adding them up, I'm just going to do the formula twice and subtract from 1. So I'm going to go 1 minus the probability of getting exactly 7 correct minus the probability of getting exactly 8 correct. Okay, and then do this calculation. So I'm going to go 1 minus 8c7 times 0.25 raised to the 7th minus, missed part, times 0.75 raised to the 1st minus 8c8 times 0.25 raised to the 8th times 0.75 raised to the 0. And do this calculation. And it ends up being 0.9999619. So again, let's make sure this makes sense. Again, 25% chance of getting a question right. 8 questions, you'd expect to get about 2 correct. So what are the chances that you'll get 6 or less correct? That should be pretty high. Okay. All right, guys, this is the last section of this chapter. Tomorrow we'll kind of review all of the combination, permutation, and binomial theorem stuff as well. So if you have questions on that, please bring those tomorrow, and we'll talk about whatever you guys need to talk about, and your test is on Friday. So we'll see you tomorrow.